Okay, now I share it back. Okay, so while waiting for our classmates, so let us just start our lesson today. Okay, so the topic is, if you refer to our textbooks, it is in chapter 4, superposition, convolution, and correlation. So we learned yesterday that for graphical convolutions, or if we want to do convolutions, there is a mathematical equation for that. So convolution is a mathematical tool to calculate the output of LTI system when the input and the impulse response are available. Okay, so we learned yesterday that the output is HT, the impulse, convolved with the inputs, or it is actually the summation of overlapping area of these two signals. So we do the integrations to calculate the overall areas of the overlapping to calculate the total sum of overlapping areas. Okay, so the formulation for the convolution is integration for the time limit here, interval. So the two signals, we, based on the 4 steps that we discussed earlier, we have to first convert the signals, replace the t with the tau, and then one of the signals has to go through the shifting and reversals transformation of signals, and we integrate it with d tau. Convolution is an integral that expresses the amount of overall overlap of one function when it is shifted over another functions. I also shared with you the GIF simulations to explain how we have this amount of YT. It is actually the total overlapping areas. So the convolution integral may be evaluated by plotting the function of xt times x tau times ht minus tau, or the other way around. So we reverse and integral the other signal, in this case the xt minus tau, and then times with h tau versus tau, and then evaluating the area under the curve. So graphically, so today we will discuss about, we will try to understand the concept of this by replacing one into to another, and then we will look into the exercises. Okay. Okay, so let us recap the steps. So first, sketch the graphs of the two signals and replace the variable of t to tau from the two signals, and one signal will remain. Okay, so if you choose the x tau to remain, so it will be static there, and one function will be reversed and shifted. Okay, so if we choose the h, first we have to do the time reversal, so therefore the ht will turn into h minus tau. H tau will turn into h minus tau, which we learned in our time transformations topics. It is called time reversal. And then we shift that to amount of t. Okay, let's say we have a value of t. Okay, so when we do the shifting, positive t, it will be shift to the left. Okay, so therefore a positive value of t shift ht minus tau to the left. Okay, so start with t minus tau, and this is called the ht minus tau is called the time shifting, reversal shifting, and then we multiply ht minus tau with xt to become x tau ht minus tau, and then we integrate. So the sum is called the sum of the total integration is the yt, and then we go back and so on until we have the overall total areas. Okay, so let us look into one example. Okay, so class, we have these examples. Let's say we have two signals. The first one is GT, which is a sawtooth. Okay, a sawtooth diagram with the gradients is 1. So therefore, our GT is T for T more than 0. Okay, and then another signal, which is UT. ut is the step input, which is given here, ut equal to 1 for t more than 0. Okay, so this is actually GTT for 0 to t only, 0 to 1. Okay, so now how do we go about to do this convolution? So let us apply the one that we did yesterday. Yesterday we learned about doing convolution with two square wave signals, two rectangular signals. So now we have one of it is the sawtooth, and then another one is the step input. So how do we do that? So just follow the steps. Okay. Okay, so replace these signals with the t to tau from the two signals, and one will remain and another one will be shifted. Let's say we choose the u to remain, and the one that will be shifted and flipped will be the g. This time dia pakai lambda, so lambda tau sama je lah. Okay, so in this case this is g lambda. Okay, so let us do that. Okay, go back to the signal. Okay, so we have one. So kita tukarlah kepada, we do the step 1, 2, and 3. The u t remain. So this is x tau. Then the one that we have for signal tadi, initially the signal is something like this, the gt, yeah. One. So this is the signal. Okay, so when we shift and when we flip and shift, so the signals will look like this. Sini akan. So this because the so this will be h t minus tau. Okay. So step 1, 2, and 3. So 1, 1, yes. Okay. So this is the signal. So initially, we have that initially the xt x tau is remain 1, and then the g t minus tau. So initially gt tadi kita ada t, ya. Okay, so now the t has been replaced with t minus tau. So now signal is t minus tau. Okay, so let us see how well this signals looks like if it is start to move. We move the red one. Kita movekan h ni, bukan h, sorry, the g. This is actually g. To see the overlapping, yeah. Okay. So jangan confuse lambda. Kat sini saya tulis lambda, lambda tahu sama saja. Okay, so we have this signal. So how will it looks like? Okay, so kita tengok. So that for yt, so for yt, which is x t convolve with gt, so there will be if a certain condition. Okay, the first one we learned that when t is less than 0. So what happened? There is no overlapping. Okay, no overlapping. So therefore our yt will be 0. Okay, now let us move our signal here. Start to overlap. Okay. So this is x tau. Cantik. And then let us sketch how will the signals looks like when it start to overlap. So this is t minus tau, and then this is t, then this is t minus 1. Why minus 1? Because of this 0 to t here. Okay. So therefore, the overlapping will be here until, so the limit of t will be until some bila class. So the next phase that we're looking at is, okay, between t 0, between t 0 and 1 lah. And 1 bila dia start overlapping, or fully. Sekarang ni partially. Now it is partially overlapping until it will fully overlap to one another at t equal to 1. So therefore we look the time between 0 to 1. Okay. So what is yt? Partially overlapping. Apa dia kelas? So what is the limit here, the interval here? Shall I put?
0 to t.
0 to t, yes. 0 to t, if you look here. 0 to t. So kita ada xt is 1 times with t minus tau, d tau. So teruskanlah. So saya just kita tengok pada solution here. Oops. Okay, so this is a gt minus tau. And then, okay, when we do the integration, so this will be the answer. I just copy sajalah answer ya. So t tau minus tau square over 2. Okay, so for between 0 to t, so I just copy the answer, which is t square over 2. Okay, so this is at condition or at phase or at condition number 2 between 0 to 1. And then we look at what happened when the signal will be fully overlapping and so on, because the u here is continuous infinity. So dalam case ini dia ada 3 case sahajalah. Okay. So this is when our signal will be, saya tak tunggu kat sini, when our signal will be fully overlapping. Okay. Saya bawa jauh sikit lah. Mana-mana pun boleh, mula-mula pun boleh, tak apa kat sini pun boleh. Kat sini pun boleh. So fully overlapping between t to t minus 1. Okay. So this will be the third condition, fully overlapping and so forth. Okay. So it will be t more than 1 lah, sebab lepas tu dia sama je t more than 1. So our yt will be in this case class, dia punya dalam ni sama 1, because the inside here is the integration is x tau h t minus tau. So the value here will always be the same lah, which is 1 times t minus tau d tau. Sign in. Can you still see my screen, class? Okay. So the only differ is the limit. So in this case it will be t to t minus 1. Okay. So the inside here, so saya kuningkan, sama Macam kita buat last time, kita buat dekat exercise before ni, yesterday pun sama. The only different limit. Okay, so ni limit dia yang ini. So that's why you have to sort of like sketch this graph. So you have to sketch this graph so you have the idea. Okay, so ni pun sama. T to T minus 1. So let us look the answer. I just copy the answer, which is, okay, so sama T minus tau, D tau, so T tau minus 1, half a T squared over, tau squared over 2. So this time the limit is T minus 1 to 1. The answer is 1. Okay, so the answer is 1. Okay, so the answer is 1 here. Okay, so only 3 conditions. Therefore, we have our YT. Tak muat. Saya buat kat sini lah. T equal to 0 T squared over 2 dengan 1 tadi. Okay, T less than 0, T between 0 to 1, T 1. Okay, so let us look at the silap setengah. This one half Okay, saya tukar balik. So saya buat half half. Okay. Okay, so let us look how it looks like. So something like this. Okay. Any question? Clear, class? Hello?
Clear, doctor.
Okay.
Clear.
Okay, clear. So the next one will be, what if we look the other way around? Okay. The other way around, meaning that now I choose U instead of G. So I choose U, the one to be flipped and shifted. Flipped to be flipped and shifted. Okay, so let us look at how well it looks like. So therefore, our YT this time will be integral terus from infinity minus infinity to infinity. So this time the X tadi kan? X tau T minus tau T tau and then G tau D tau. So let us imagine how will it looks like. Okay, so this is the minus tau G. So the G remains. Okay, the one to be shifted is U lah, X dalam case ni. So okay. So signal kita ni dia jadi T minus tau. So this one. Okay, kenapa saya merahkan? Tak apalah. Okay, so let us, the same thing, it will have 3 conditions. So let us look condition 1, 2, and 3. So when T less than 0, so of course our YT, no overlapping, it will be 0. And then let us look how it looks like when the red one is moving towards the first signal. Okay, so saya buat sini. Okay, so this is the overlapping area. And then the the limit will be between 0 to a t, 1, t, this is g tau, this is u dx. X t minus. Okay, so let us look at the conditions until 1, same sama macam condition tadi. So t more 0 until 1. So our yt will be, so we look at the limit is between 0 to t. Okay, again the same signal, g tau is tau. Okay, and what about the signal 1, the signal u? Dia remain lah. Okay, they remain as 1. Okay. Okay. D tau. Okay, here 0 to t, and this is the second signal that we shifted. And then bila kita buat, kita dapat the tau squared over 2, which is 1 over t squared. And the third one also, let us imagine the same actually. Saya buatkan dia lebih lah. Macam tu. Tunjuk. Okay. So this is x. Xt minus tau. G tau. Okay. So again, the overlapping. Okay, between. Dalam kes ni kelas, between apa? What will be the, so t more than 1, eh? Yes. So, t more than 1. Okay, so kalau kita tengok sini 0 to 1. Okay, yang ni t. Okay, so t more than 1. So the signal will fully overlap. So the limit will be between 0 to 1. So sama tau and 1 t tau. Okay. Oh. Okay, so we shall have the same answer. Okay, so you can see the difference here. First one, when I shifted the G signal. The second one is when I shifted the step input signals. So it should be the same. So the complexity in this case is about the same. But sometimes the choice of what signals to be flipped and shifted will affect the complexity of the calculation for the convolution here. Okay, so saya balik habiskan sebab saya kalau tulis macam ini kan nanti semua kelas buat macam ini. So I put the answer should be the YT. So 0, t squared over 2 and 1 over 2. So t less than 0, t 0 to 1, and t more than 1. Okay, so this should be the final answer. Sometimes we require you to, and it would be good if you can sketch. But if the the signal is sort of like complicated.